And welcome back to our water pollution unit, where in this podcast we're going to be taking a look at groundwater pollution and then also how do we treat our drinking water. The first thing you need to understand is that it's a very complex system, groundwater, and so in order to purify it and use it as a source of drinking water when it has been polluted is going to be very, very expensive. So again, prevention is going to be the least expensive and the most effective strategy. So the deal is with drinking water, with groundwater, about half the U.S. population gets its drinking water from groundwater. And so some of the common pollutants that we're going to be concerned about are going to be fertilizers and pesticides from farm fields, gasoline leaking from underground tanks, organic solvents that leach downward through the soil profile, and fracking, which is a way of releasing natural gas and oil which is used quite a bit in Pennsylvania and then also out in the Dakotas. And so that's something that we need to be able to discuss. The problem with groundwater is that it's such a slow-moving system. It's not like the pollutants are going to be carried away. Oftentimes, groundwater is only moving, on the order of a foot per year. It could be even going slower than that, where rivers are traveling miles and miles per day. The other thing that's going on in the ground, there's not a whole lot of dissolved oxygen in this water. There's not as much bacteria if we're dealing with organic pollutants or biodegradable pollutants, and the temperatures are relatively low. And all chemical and biochemical reactions go slower at colder temperatures. So even if the conditions are right down there to biodegrade, it's going to happen much, much more slowly. And so those all pose challenges. There's a lot of different places that or activities that can contaminate groundwater. If we start in the upper left-hand corner here, when you're dealing with strip mines, we'll talk in the mining unit about acid leaching, which essentially what happens is the water from the atmosphere is going to react with sulfur in the sulfide mines, and now you have sulfuric acid that's going to be moving downward, pulling with it metals out of the ores, and that can contaminate groundwater. You also have waste lagoons that we showed you earlier in this unit, which, if they're not lined properly, can leach nitrates and phosphates downward, as well as bacteria and viruses. You have unlined landfills that can leach particularly toxic metals downward into aquifers. Other sources are going to be gasoline stations, where at gas stations where you have your buried gas tanks that can leach downward and without even realizing it. We have surface runoffs that can eventually make their way down through the soil profile, road salts, fertilizers, pesticides, etc. When you're talking about sewer lines can leach and leak obviously sewage and bacteria and whatnot downward. You also have buried septic tanks if they're not properly maintained. And then we'll talk later on in the course about hazardous waste management, and one strategy is to inject that waste downward into geological formations. But if the casing is not correct, you can leach that hazardous waste into groundwater. So all of those are going to be concerns, particularly for people who get their drinking water from the ground. And reports state that 90% of urban aquifers are contaminated in China. But this is not necessarily just a Chinese problem. We have issues here in the U.S. as well, particularly with nitrate ions out in the Great Plains. And so when nitrate ions from fertilizers make their way down into the groundwater, mothers will make infant formula out of that groundwater, and the nitrates, as the babies ingest them, prevent them from taking oxygen into the blood, and you can have what's called blue baby syndrome, which can be fatal. And so that's also a real issue here in the U.S. Another issue with groundwater contamination is arsenic. There are natural formations of minerals that contain arsenic, that particularly when you have acid leaching from mines, you're going to have that arsenic that can be drawn downward into groundwater, and arsenic is a known carcinogen. Now, there's different ways that we can purify our drinking water, and we're going to go through each of these. The most common way, at least here in the States, is going to be through purification plants, and there is a wonderful video posted on our Canvas page that walks you through step by step, and we'll be doing that shortly here as well. Some people will process sewer water to drinking water. That's not what we do here in the U.S. We're going to treat the sewer water at a treatment plant, discharge it into our waterways, and then in a separate process, purify our drinking water through a drinking water purification plant. In lesser developed countries, they're going to be exposing water through with UV light. You just put your water in clear plastic bottles and expose it to sunlight, and that can kill some bacteria. It doesn't do anything with if you have metal contaminations, but it can denature viruses and kill bacteria. You also have some products such as the Life Straw and this PUR, which is a chlorine iron sulfate powder that can be used for treatments. There's other ways that people do. If you're a hiker, you have iodine tablets, and there's other types of ways of purifying the water. But these are some major ways. So let's talk about water treatment plants and some of the basics of it, at least here in the States. So starting in the upper left-hand corner, you're going to be taking water in from some water source. Where I am, we take it in from Lake Erie. There's a pipe that goes about a mile out into the lake. Many of you will be getting your drinking water from the Detroit River, just north of Belle Isle, and some of you could be taking it from Lake Huron. But it all involves the same general processes. So the first thing you have is the physical treatment. This is the primary treatment, where you're going to be removing the objects through a bar screen and other types of screens to sift out the things that are floating in the water, sticks, debris, etc. Then when you're going to have this coagulant treatment. Coagulants, what they do is they take all of the soil particles and anything else that's floating in there that's organic, and they'll help bind them up into larger particles. And those larger particles are called flocks, F-L-O-C. And so those flocks then will be grouped together in a tank, which is being stirred up. It's a process called flocculation. And those flocks, once they're grouped up into larger and larger particles, they get settled out over here, number 8, in sedimentation basins. There's actually a couple ways. In some cases, they will bubble in air, and then they'll bubble up the flocks to the top of the surface, and they'll skim them off. So there's different strategies for getting rid of those flocks. But those flocks, they're removing large portions of solid materials. With most of the materials now removed, you now have small microscopic types of things. And so then you're going to pass them through, in this case it's called anthracite, but it's an activated an activated carbon. That's actually oftentimes used in fish tanks. They'll pass them through this activated carbon, sand, gravel, or mixture thereof, and that's going to pull out all the smallest of the materials. And now the water is essentially clear and free of debris. You still have viruses and bacteria and those types of things that you got to be concerned about. So now you're going to be moving it into another treatment of chlorination. Sometimes they'll use UV light, sometimes they'll use ozone, and sometimes they'll use a mixture of them. And the chlorination, UV light, ozone will kill bacteria and viruses, etc. Finally, there's going to be another set round of treatments. Here in the U.S., oftentimes we will add fluoride to the water, and that fluoride is designed to help with hardening your teeth to prevent cavities and whatnot. And in other cases, they'll also use what's called orthophosphate, and that orthophosphate is designed to prevent corrosion in the water lines. If you know anything about the Flint water crisis, part of that had to do with the corrosion of pipes because of the chlorides in the water. And if you add orthophosphates, it will help prevent the corrosion of those pipes where lead and potentially copper can be leached into the drinking water, and that can prevent that. So once those treatments have been added, now you'll pump that water up to the top of the water tower, and so you have to add energy to do that. So now it's at the top of the water tower, and now gravity predominantly works, where gravity just pulls the water down and is going to distribute it to homes and businesses, etc. There are places where they will use additional pumps to help move the water along, but it's predominantly done by gravity by that point. So that's your water treatment and water distribution system that's pretty typical of systems here in the U.S. Other ways that you can purify water in those areas that do not have that kind of infrastructure, you have these life straws. These life straws use a series of microscopic pores and membranes, and so people can literally just draw the water through the straws, and as the water is pulled through the straws, metals, microbes, etc., are literally filtered out. And these are relatively inexpensive. I want to say they're $20 a piece, at least some of the places that we've checked, and they can be used in rural villages worldwide. Other options are using a treatment of chlorine and iron sulfate powder to disinfect, and then the iron sulfate can help pull more solid material out of the water, and so that's also an option. Now, here we also use bottled water. Now, the deal with bottled water, a lot of people just assume bottled water is better water, but in fact, bottled water is actually very expensive. It can be useful, but it's actually much more expensive than what you're going to get from your municipal water. And in some cases, it's just municipal water. Now, here in the U.S., we have some of the world's cleanest water because it's so highly regulated, but bottled water is actually less regulated than our tap water. And so that in and of itself, it doesn't necessarily mean that the bottled water is bad, but it is less regulated, so you're not quite sure what you're getting in some cases. You also have the issue with the plastic and that the bottled water comes in. And so most places now are installing refillable water stations with their drinking fountains so that people can bring their refillable waters, and that can help crack down on the plastic pollution that's littering our oceans. We talked about the regulation of drinking water, and you need to know the 1974 U.S. Safe Drinking Water Act that sets what's called maximum contaminant levels for various pollutants. And so if we go over to the EPA website, you're going to notice that they manage or regulate microorganisms, disinfectants and their byproducts, inorganic chemicals, and if you go take a look at inorganic chemicals, we're talking predominantly about metals and some of the anions. And so these maximum contaminant levels, MCLs, there's two types. You have the goals, and then you have the acceptable levels. And then we move down to notice here's copper. These are all in parts per million, by the way. And so you'll notice lead. The goal for lead, for example, is that you want to have 0 lead in the water. There's no safe known amount of lead. However, they will allow them to have 0.015 parts per million, or that's 15 parts per billion, before you have to take action. So if you have small amounts of lead, even though they don't want that, it's really an issue of cost. There's no cost-effective way to get rid of all of the lead, and so they actually set a small amount at which, if it's below that, they're going to deem it okay. Mercury, same thing. There's really no known amount of mercury that's acceptable, that's healthy, but they do set that at about 2 parts per billion, in which case then you're going to deem it unsafe. So and they also do run this. If I scroll down, here's going to be your organics. These are going to be a lot of pesticides, other types of organics. You'll notice chloridane, 2,4-D. Those are all things that you should remember from Silent Spring. Okay, so those are maximum contaminant levels that the U.S. Safe Drinking Water is going to set. All right. So in the next podcast, we're going to take a look at our major water pollutants as they impact our oceans. We'll see you next time.